Okay, your laws of exponents or rules for exponents are these. So, just as examples, x to the a times x to the b always equals x to the a plus b. For example, 2 to the third times 2 to the fourth should equal 2 to the 3 plus 4. And that's the case. 2 to the third is 8. 2 to the fourth is 16. And this should equal 2 to the seventh. So this is 128, should equal 2 to the seventh. Well, 2 to the seventh is 128. Multiply it out. 2 times 2 times 2 times 2 times 2 times 2 times 2. It's going to be 128. So this sort of justifies the rule. But to prove the rule, we would say that we write this out as x times x times x times x, a times, there's your x to the a, and you multiply that by x times x, etc., ending up with x. This is b times and this would be a plus b times, and clearly this is true. If you got a of them here and b of them here, then on this side you got a plus b of them, and over on this side that's exactly what you've got, so it has to be equal. So we have this law, this rule for exponents, always has to work, at least for positive numbers. Now, you get into negative exponents, well, let's look at an example of a negative exponent here. Okay, x to the negative a is 1 over x to the a. So like 2 to the negative 4 should be 1 over 2 to the fourth. Simple enough. Okay, and of course, we understand this law is very important for evaluating, for example, the exponential function, if you were able to do that. At 2 to the negative 1, 2 to the negative 2, if you're making the table, we have to have this rule. And this rule makes sense because, in this case, two to the negative fourth times 2 to the fourth would be what? Well, it would be 1 over 2 to the fourth multiplied by 2 to the fourth. And we'll put that over 1. Well, that equals 2 to the fourth over 2 to the fourth. That should equal 1, right? 2 to the negative 4 times 2 to the fourth should equal 1. And by the first law, 2 to the negative fourth times 2 to the fourth equals 2 to the 0. Now, using this rule, it equals 1. So 2 to the negative fourth times 2 to the fourth by the third rule should equal 1, and we see that it does. Now, there's a little more to it, and I haven't really proven anything, but except I've pointed out a certain amount of consistency here. Why is 2 to the 0 equal 1? It's not because of this, because of this, because of that. This happens because of this. It gets a little circular. But we're not going to worry about it. This illustrates, though, one of the reasons we want 2 to the 0 to equal 1. Okay? So that illustrates the third rule. And of course, this rule is very important because we need it to evaluate the standard values for the basic exponential function. Okay, we need to be we need to be able to take 2 to the negative power. We need to be able to take 2 to the 0 power. And of course, this whole thing about any number to the 0 power equals 1, it doesn't apply to just 2. We can do the same thing with 400. 400 to the negative 4 times 400 to the 4th. It's going to be 1 over 400 to the 4th times 400 to the 4th, and everything's going to come out the same. So, very important to understand these rules, especially at this point of the course for evaluating the basic functions at the standard points. Okay, then of course we have x to the a to the b equals x to the a times b. So like 2 to the 3rd to the 4th equals 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. Need another one. That's 8 times 8 times 8 times 8. Everybody knows that's 4,096. Okay? Well, okay, let's write it out. 2 to the 3rd to the 4th is 2 to the 3 times 4 by this rule, which means it's 3 times 4, not 2 times 4. 2 to the 3 times 4, which is 2 to the 12th. And 2 to the 12th, multiply it out if you like. 4,096. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256, times 2 is 512, times 2 is 1,024, times 2 is 2,096, times 2, 2,090, wait a minute, 2,048. Multiply that by 2, you get 4,096. And that was 12 of them. Okay, you can check it out yourself. Okay, so this kind of illustrates rules for exponents, and these rules also come about in simplifying algebraic expressions.